This new hypersonic air fighter can fly at extreme speeds no other fighter has ever dared achieve. Before the development of this $700 million air fighter, the United States Blackbird was renowned the fastest fighter jet that has ever been created, flying at a speed of Mach 3.3. However, this new fighter exceeds that, reaching an exceptional speed of Mach 10. It is not only fast, it is more technologically advanced than. What is this air fighter that is more advanced than the Blackbird? What makes this fighter so unique? Join us as we explore the capabilities of the new $700 million hypersonic aircraft that has been kept a secret. Speed has always been a very important feature in any military weapon, and that was one amongst other things that the SR-71 excelled at well until it got retired. To replace it, the United States has developed a new air fighter with features that surpasses even the most advanced aircraft ever developed in the history of military aviation. This new air fighter is known as the son of Blackbird, a successor of the formidable Blackbird. The first news concerning the Blackbird's successor surfaced in 2007 when leaked information about a United States Air Force contract with Lockheed Advanced Development Projects revealed plans for a groundbreaking aircraft. This new aircraft was designed to fly at speeds exceeding Mach 6 or over 4,600 miles per hour and with the ability to fly across continents at an altitude of 100,000 feet in November 2018. The SR-72 came back into the spotlight after several years of unconfirmed rumors about the fighter. This time, Aviation Week in Space Technology unveiled exclusive insights and information from the Skunk Works team, causing their servers to crash under the weight of public interest in DOS attacks. The article detailed Skunk Works' ambitious vision to develop an affordable ISI or intelligence surveillance and reconnaissance hypersonic strike platform. This twin-engine aircraft was designed to penetrate enemy airspace at exceptional speeds and altitudes, a sweet spot for hypersonic air-breathing weapons, as Lockheed Martin described it. But that is not all that makes this aircraft unique. The SR-72 would operate where even the most advanced subsonic or supersonic aircraft and UAVs would falter. Moreover, this aircraft promises to strike targets before they even realize it is there, effortlessly evading detection and evoking a new era of hypersonic reconnaissance. This aircraft is set to redefine hypersonic aviation, far surpassing the capabilities of its predecessor, the legendary SR-71 Blackbird. First proposed by Lockheed Martin in 2013, the SR-72 is designed to reclaim the rare reconnaissance capabilities that were lost when the SR-71 was retired in 1998. Despite advancements in stealth technology which gave rise to radar-evading fighter jets and drones, the need for extreme speed in reconnaissance missions has remained constant. Developing this technological marvel was not an easy task. Let's explore the process involved and challenges encountered in building this air fighter with outstanding characteristics. During the search of a new fighter that would replace the Blackbird, Lockheed Martin faced several challenges. These challenges led to the creation of the Hypersonic Technology Vehicle 2, or HTV-2, under DARPA's Falcon project. This automated rocket launch vehicle, which was designed to navigate the Earth's atmosphere at hypersonic speeds, achieved a stunning Mach 20, approximately 20,900 kilometers per hour, in its test flights in 2010 and 2011. This technology could theoretically strike any target on the globe within an hour. This ambitious principle laid the groundwork for the larger Prompt Global Strike Initiative. This aircraft was built from robust carbon composite materials to protect its critical components from the intense heat generated at such high speeds. With surface temperatures soaring above 3,500 degrees Fahrenheit, conventional steel was out of the question because it would have melted at around 2,500 degrees Fahrenheit. The HTV-2 was meant to pave the way for the HTV-3X, also known as Black Swift, which was supposed to be a reusable hypersonic cruiser or drone capable of taking off from a conventional runway. This futuristic craft was designed to carry a payload of approximately 12,000 pounds and strike targets up to 10,350 miles away in under 2 hours. Despite the promising data gathered from the first two HTV-2 tests in 2010 and 2011, the third flight and future versions were cancelled. However, the work on this technology continued until the summer of 2014. The focus was on making use of the lessons learned to enhance the tools and methods for designing high-temperature aerodynamic shells, pushing the boundaries of what hypersonic technology could achieve. Now, let's get back to the year 2013, a significant year for Skunk Works and Aerojet Rocketdyne. Before unveiling a glimpse of their global ambitions to Aviation Week, Skunkworks had been collaborating with Aerojet Rocketdyne for over 7 years. Their mission was to develop a revolutionary method for integrating a hypersonic engine with scramjet, propelling an aircraft from a standstill to speeds exceeding Mach 6. The foundation for this groundbreaking approach was the cancelled HTV-3X. But Lockheed and Aerojet's advancements far surpassed the initial design, successfully solving one of the most complex technical challenges, the high-speed gas turbine engine. Today, the United States is leading over a dozen advanced hypersonic programs, with the SR-72 often linked to the shadowy Mayhem project. This secretive U.S. Air Force initiative aims to create expandable test beds for next-generation jet engines, including advanced turbine-based combined cycle designs. While conventional jet engines rely on a centrifugal compressor or rotating fan blades to compress incoming air, scramjet engines take a different approach. They leverage the immense pressure of high-speed airflow to achieve higher velocities than traditional jets. However, scramjets falter at lower speed where insufficient air pressure makes landing impossible, relegating such engines to one-time use. Then the combined cycle scramjet engine, which is a game-changer that merges a traditional jet engine with a scramjet, allowing the aircraft to operate like a conventional plane and be reused multiple times. Aviation experts and engineers believe this revolutionary engine will transform both defense and air travel. While no country has yet succeeded in integrating a scramjet into a rocket or aircraft, the United States is making significant strides towards this ambitious goal. In the fall of 2021, Northrop Grumman successfully conducted a scramjet flight as part of the DARPA HAWK program. And by March 2022, Lockheed Martin had joined the ranks with successful hypersonic weapon tests. The Mayhem project builds on the scramjet concept pioneered in the HAWK program, but takes it a step further, incorporating only part of the combined cycle needed for the SR-72 success. The Air Force still faces some challenges in powering a traditional jet engine without obstructing the scramjet's airflow or adding excessive weight. Abandoning the invisibility race, United States hypersonic developments now focus on achieving exceptional speeds. This strategy allows aircraft to penetrate enemy territory, gather crucial data, or strike targets before retreating at lightning speeds. The key to achieving this are the components designed to withstand the extreme temperatures encountered at Mach 5 to 6. Both materials and electronics must endure high-speed flight while maintaining stable communications and executing precise maneuvers under peak load conditions. Despite the technical success, hypersonic weapons come with a mind-blowing price tag. The Pentagon estimates current hypersonic missiles cost between $90 million and $110 million each. For perspective, the latest Lockheed Martin F-35, a Lightning II stealth fighter, costs $80 million. This difference in cost might lead to the preference for the old Blackbird, which cost only $23 million per plane in the 1960s. However, the SR-72's advanced capabilities far surpass those of its predecessor. Also, the cost of developing aircrafts in the 90s can't be compared to now. Former Lockheed CEO Marilyn Hewson noted that a prototype Blackbird successor would be similar in size to the F-22 Raptor and cost under $1 billion. While these figures are speculative, they gain credibility considering the B-21 Raider strategic bomber's estimated cost of $700 million per unit in December 2022. In June 2017, when Lockheed Martin's Executive Vice President and General Manager of Advanced Development Programs, Rob Weiss, confirmed in an interview with Aviation Week that hypersonic technology had matured significantly. Weiss revealed that Lockheed, in partnership with DARPA and other agencies, was diligently working to integrate these new capabilities into the U.S. fighter fleet in future developments. While Weiss remained tight-lipped about the specifics, citing the sensitivity of the project, his comments, along with those of former Lockheed CEO Marilyn Hewson, underscored the critical importance of integrating the combined cycle engine and other cutting-edge technologies essential for hypersonic flight. Now, let's get into the design of the SR-72 and compare it to that of its predecessor. The initial plan was for a smaller demonstrator. However, the SR-72 will eventually mirror the size of the SR-71 over 100 feet long and match its operational range. While the United States Air Force initially hesitated to fund the SR-72 due to budget constraints and the emergence of alternative surveillance technologies like the Northrop Grumman RQ-180 stealth drone, the potential of the SR-72 remained appealing. The United States is not the only nation that contributed to the development of this technological marvel. NASA has also contributed to this vision by awarding Lockheed Martin contract to explore propulsion technologies, aiming to bridge the performance gap between turbine and scramjet engines. As of 2023, the development of these advanced engines continues with Lockheed Martin using existing turbofan technology to achieve unprecedented speeds. In 2018, Lockheed Martin hinted that the SR-72 might make its first test flight by 2025 with a goal of being operational by the 2030s, the same period the sixth generation of airfighter NGAD would be operational. Right now, the project remains a design proposal aiming to create a hypersonic super-fast drone for long-distance spying. Given Lockheed Martin's expertise, it's expected to feature cutting-edge technology and exceptional capabilities. One question remains in the mind of aviation lovers. Is the son of Blackbird also known as a dark star? Well, there's only one way to answer that. The SR-72 project is often mistakenly referred to as Dark Star, a name popularized by the 2022 movie Top Gun Maverick. The SR-72 is not the Dark Star. Amid these advancements, the U.S. military is also pushing forward with other next-generation aircraft projects. The FOAXX program, a successor to the aging FO-18 in the Air Force's Next Generation Air Dominance NGAD program, are part of a broader strategy to maintain aerial superiority. These initiatives involve developing sixth-generation fighters with advanced connectivity, AI integration, and adaptable mission capabilities. Competing globally, the U.S. plans to lead in the development of sixth-generation fighters. However, they are facing challenges from international projects like the UK's Global Combat Air Programme and the European Future Combat Air System. Despite these challenges, the United States remains the most technologically advanced nation in the world. Now, let us make a very complex comparison between the predecessor of the SR-72 and the another technological marvel, the Lockheed A-12. The Lockheed A-12 is a retired high-altitude Mach 3 plus reconnaissance aircraft that was built for the CIA by Lockheed's legendary Skunk Works, masterminded by the Clarion's Kelly Johnson. This aircraft, known internally as the Archangel, represents the peak of 12 design iterations. In 1959, it triumphed over Convair's Fish and Kingfish designs, emerging victorious in Project Gusto and evolving under cloak of Project Oxcart. Initially, CIA representatives leaned towards Convair's design due to its smaller radar cross-section. However, the A-12's superior specifications and significantly lower projected costs was later preferred. Convair's history of delays and cost overruns with the B-58 contrasted sharply with Lockheed's record of delivering the U-2 on time and under budget. Additionally, Lockheed's skills at managing top-secret black projects sealed the deal. Produced from 1962 to 1964, the A-12 had its very first flight in 1962. Between 1963 and 1968, it laid the groundwork for the twin. Seat United States Air Force YF-12 prototype interceptor, the M21 launcher for the D-21 drone, and the SR-71 Blackbird. The SR-71 is a slightly elongated version of the A-12, and it has the capability to carry more fuel and cameras. The A-12 commenced missions in 1967 with its final sortie in May 1968, before the program's retirement in June of that year. However, the A-12's existence remained a secret until the mid-1990s when it was officially declassified. It wasn't just an aircraft. It was a symbol of Cold War ingenuity, embodying the relentless pursuit of technological supremacy and the covert operations that defined the era. Reflecting on its codename origins, a CIA officer noted that the Oxcart was selected from a random list of code names to designate this R&D and all later work on the A-12. The aircraft itself came to be called that as well. Embracing Lockheed Martin's tradition of special naming, the crews nicknamed the A-12 Cygnus, a name which was proposed by pilot Jack Weeks and aligned with the company's practice of naming aircraft after constellations. How was the A-12 developed? With the failure of the CIA's Project Rainbow to reduce the radar cross-section of the U-2, Lockheed began to lay the groundwork for a groundbreaking follow-on aircraft to overfly the Soviet Union in late 1957. Legendary designer Kelly Johnson remembered in April 1958 that he had extensive discussions with Richard M. Bissell Jr. about the necessity of a successor to the U-2. Under Project Gusto, these designs were nicknamed the Archangel, a perfect successor to the U-2, known internally as Angel. As the aircraft's design progressed and underwent various configuration changes, the internal designation evolved from Archangel 1 to Archangel 2 and so forth. These evolving designs quickly became known simply as A1, A2, and so on. The CIA's program to develop this next-generation aircraft was named Oxcart. By the time the designs reached the A11 stage, the program was up for review. The A11 was in fierce competition with Convey's Kingfish, which boasted a significantly reduced RCS, a major advantage in stealth. Lockheed's response was to refine the A11, adding canted fins and incorporating non-metallic materials, resulting in the A12 design. On January 26, 1960, the CIA greenlit the production of 12 A-12 aircraft. The A-12 project pushed the boundaries of aviation technology, necessitating the invention of new materials and production techniques, some of which remain in use today. One of the greatest challenges was working with titanium, a material both revolutionary and notoriously difficult to handle. In his memoir, Skunk Works, a personal memoir of my years at Lockheed, Ben Rich recounted that their supplier, Titanium Metal Corporation, had only limited reserves of the precious alloy. The CIA conducted a global search using third parties and dummy companies to discreetly purchase the base metal from one of the world's leading exporters, the Soviet Union. The Soviets had no clue they were indirectly contributing to the creation of an aircraft designed to spy on their homeland. Remarkably, 93% of the A-12 structure was titanium. Before the A-12, titanium was used sparingly in high-temperature exhaust fairings and other small high-stress components. The A-12's construction, however, was predominantly titanium, which posed significant challenges due to the material's rigidity and difficulty in machining. This complexity made forming the aircraft's curved surfaces particularly problematic. The solution lay in machining small fillets of the required shape and affixing them to a more linear underlying framework. For instance, the wing's leading edges were constructed by filling triangular notches in the framework with these fillets. The move to the A-12 also saw advancements in RCS reduction by replacing fillets with new radar-absorbing composite materials. These composites made from iron ferrite and silicon laminate combined with asbestos-absorbed radar waves, rendering the aircraft even more stealthy. By making use of titanium and pioneering stealth technology, Lockheed's Skunk Works team crafted an aircraft that not only outperformed its predecessors, but also set new standards in reconnaissance and stealth. The secretive Marvel flew missions between 1967 and 1968. Its existence remaining classified until the mid-1990s, the A-12's legacy endures, influencing modern stealth aircraft and continuing to symbolize a golden age of aviation innovation. It was a marvel of aviation designed to be smaller, faster, and capable of reaching higher altitudes than its successor, the Blackbird. Operated by the CIA, the A-12 was a sleek single-crew reconnaissance aircraft that pushed the boundaries of what was possible in aerial espionage. In contrast, the SR-71 operated by the U.S. Air Force carried 2 crew members due to the additional safety equipment, which added significant weight. Despite their differences, the A-12 and SR-71 shared much in common. Both aircraft were powered by the formidable J-58 engines, which functioned as turbo ramjets. This innovative engine design allowed these aircraft to cruise at speeds exceeding Mach 3, making them nearly impossible to catch or shoot down. Comparing their sizes, the A-12 was around 100 feet in length, while the SR-71 was slightly longer at approximately 107 feet. This extra length on the SR-71 accommodated additional equipment and the second crew member. However, these minor dimensional differences did not detract from their shared legacy of unmatched speed and altitude capabilities. One interesting event in the A-12's history involved an attempt to adapt it into an armed interceptor, the YF-12. Although promising, this version faced numerous feasibility challenges preventing it from entering active service. One logistical challenge both aircraft faced was their fuel consumption. Operating at such high speeds required frequent refueling approximately every 90 minutes. However, at Mach 3, they could cover an astounding amount of distance in that time, making them highly efficient tools for reconnaissance missions despite their fuel demands. However, because of extreme operational costs, military strategists decided that the more capable United States Air Force SR-71S should replace the CIA's A-12s. These were retired in 1968 after only 1 year of operational missions. Thanks for watching.